2x plus y minus 3z is equal to 0 and x plus y plus z is equal to 2 using matrix methods. Instead of writing cofactor and transposing, I'll straight away go to the adjoint. Delete the row and column containing 2, 2 2s are 4, minus into minus it is plus 4. This satisfies a square minus 4a plus I is equal to 0, where I is a 2 cross 2 identity matrix. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, the faculty of mathematics, Vidhyaashram PU College, the Temple of Excellence. In the previous class, I have discussed regarding matrix method, solving the simultaneous equation using matrix methods. So, and also the adjoint. By knowing the adjoint, you will get the inverse. By knowing the inverse, you can solve the simultaneous equations. So, in the last class, we have solved simultaneous equations of two variables. Now, in this session, I am going to solve the simultaneous equations of three variables x, y and z. So, this is very important session. Whatever the problems I will solve today is very important for the point of examination. So, you will get one question from this section for part E for 6 marks. The 6 marker question, see in the examination you want to answer one 6 marks question and one 4 marks question. One 6 marks question is from this concept. Definitely you will get a 6 marks question from this concept. Now let me start with this. Now what is the first problem? So solve the simultaneous equations, that is 3x minus 2y plus 3z is equal to 8. 2x plus y minus z is equal to 1 and 4x minus 3y plus 2z is equal to 4 using matrix method. This is very important problem for 6 marks. Part E, 6 marker question this is. Now, let us verify the equations are in order or not. X, Y, Z, X, Y, Z, X, Y, Z. Write down the matrix A first. Here A is equal to coefficient of X, coefficient of X, Y, Z. 3, minus 2 and 3 for the first equation. For the second equation, coefficient of x, y, z is 2, 1, minus 1. And the coefficient of x, y, z for the third equation are 4, minus 3 and 2. You know the value of x. X is nothing but x, y, z, that is to be determined. And the constant matrix B is equal to 8, 1 and 4. 8, 1 and 4. This is what the given condition. This is the given condition. So, A is equal to coefficient of x, coefficient of y, coefficient of z, and x is equal to x, y, z, and B is equal to constant 8, 1 and 4. You know the solution. The solution is, the formula to find this solution is, the solution is x is equal to A inverse into B. X is equal to A inverse into B is the solution. What is A inverse? You know the value of A inverse. The formula for A inverse is A inverse is equal to 1 over determinant of adjoint of A. 1 over determinant A into adjoint of A. Now you know what is the meaning of adjoint of A. Adjoint of A is nothing but the transpose of the cofactor matrix. Now let us find out the cofactor matrix for A. Now let me write the determinant of A. Determinant of A is equal to determinant 3 minus 2 3, again 2 1 and minus 1, 4 minus 3 and 2. Let us find the determinant of this, plus minus and plus. So 3 into 1 into 2 is 2, minus into minus plus, plus into minus minus, 3 ones are 3, minus into minus plus 2 into, delete the row and column containing 2, 2 2s are 4, minus into minus it is plus 4, plus 3 into, delete the row and column containing this, 2 3s are 6, minus 4 1s are 4. So this is equal to 3 into 2 minus 3 is minus 1, plus 2 into 4 plus 4 is 8, plus 3 into minus 6 minus 4 is minus 10. So this is minus 3, 2 into 8, 8 is a 16, minus 30. So this is equal to 16 minus 33. 16 minus 33, this is nothing but minus 17. The value of determinant A is equal to minus 17. not equal to 0, inverse exists. The first part. Listen to me. I'll explain once again. This is very important problem. So, solve 3x minus 2y plus 3z is equal to 8, 2x plus y minus z is equal to 1 and 4x minus 3y plus 2z is equal to 4 using matrix method. Now, write down the coefficient of x, y, z. Coefficient of x, y, z in the first line. X is 3, y is minus 2, z is 3. For the second equation, x is 2, coefficient of y is 1, z is also minus 1. And the coefficient of x is 4, minus 3 and 2. And the constant matrix 8, 1, 4, 8, 1 and 4. And the value of x is x, y, z. The solution is x is equal to A inverse of B. And you know A inverse is equal to 1 over determinant of A into adjoint of A. First find out the adjoint of A. For adjoint of A, first find out the determinant. Determinant of A is equal to, for inverse, first find out the determinant of A. So determinant of A is equal to 3 minus 2, 3, 2, 1 minus 1, 4 minus 3 and 2. So delete the row and column containing this. 3 into 1 2s are 2, minus into minus, plus into minus, minus. 3 1s are 3, minus into minus plus 2. This is gone. 2 2s are 4, minus into minus plus. Again plus 3 into 2 3s are 6, minus 4. So 2 minus 3 is minus 1, 4 plus 4 is 8, minus 6 minus 4 is minus 10, minus 3, 8 2s are 16, minus 30, that is 16 minus 33 is equal to 17. So the value of determinant is 17. Now let me find out the cofactors. I will go to the next page. So let us write these elements. I will take these elements. Matrix A is equal to 3 minus 2, 3. So here A is equal to 3 minus 2, 3 from the previous 3 minus 2, 3. 2, 1 minus 1, 2, 1 minus 1. Again 4 minus 3, 2. 4 minus 3 and 2. Now write down the cofactors. The signs are plus, minus, plus, minus, plus, minus, plus, minus and plus. Write down the cofactors and find out the adjoint. So the cofactor of 3 is equal to, this row column is deleted, 1 2s are 2, minus into minus, plus into minus, minus 3 1s are 3, this is equal to minus 1. Similarly, cofactor of minus 2 is equal to minus out, 2 2s are 4, minus, this is gone, minus into minus plus, this is equal to minus 8. Similarly, cofactor of 3 is equal to, this row column is gone, 2 3s are 6, minus 4, this is minus 10. I will write the cofactor matrix here. C is equal to, first row contains minus 1, minus 8 and minus 10. Come to the second row. So cofactor of 2, the sign is negative, minus out, this row column is deleted, minus 2 2s are 4, minus into minus plus, 3 3s are 9, 9 minus 4 is 5, the negative sign is out, minus 5. Again, cofactor of next element 1, this row column is gone, 3 2s are 6, minus, this is gone, 4 3s are 12. So 6 minus 12 is equal to minus 6. Similarly, the cofactor for this minus 1 is minus out, this is negative sign, this is gone, 3 3s are 9, minus 9, minus into minus plus, 4 2s are 8. So minus of minus 1, this is equal to plus 1. So I will write here, I will write the second row, minus 5, minus 6, minus 5, minus 6 and plus 1. Now come to the last row. The cofactor of 4 is equal, it is a positive sign, this row and column is gone, minus into minus plus, 2 1s are 2, minus, yes, 1 3s are 3, yes, this row column is gone, minus into minus plus, 2 1s are 2, 1 3s are 3, that is minus 3, that's equal to minus 1. Similarly, the cofactor for minus 3, it is negative, minus, this row column is gone, 3 1s are 3, minus 6, minus 3, minus 6. So that's equal to minus of minus 9 is plus 9. And last element, cofactor for the last element 2 is equal to, this row column is gone, 3 1s are 3, minus into minus plus 2 2s are 4, that's equal to 7. So the values are minus 1, 9 and 7. This is the cofactor matrix. Let me check once again. I will check once again. I will explain once again. So the cofactor of 3, this row column is gone. 1 into 2 is 2, minus into minus plus, 3 ones are 3. So 2 minus 3 is minus 1. Cofactor of minus 2 is minus, this row and column is gone, 2 2s are 4, minus into minus plus, 4 plus 4 is 8. Cofactor of 3 is, this row and column is gone, 2 3s are minus 6, minus 4, minus 10. So in the first row, minus 1, minus 8, minus 10, correct. Second row, cofactor of 2, it is negative. This row and column is gone, 2 2s are 4, minus 4, minus into minus plus, 9 minus 4 is 5, this negative sign out, minus. Cofactor of 1, this row and column is gone, 3 2s are 6, minus 12, 6 minus 12 is minus 6, correct. The cofactor of minus 1 is negative out, this is gone, 3 3s are 9, minus into minus plus, 9 plus 8, minus 9 plus 8 is minus 1, minus into minus plus, correct. Last row, the cofactor of 4, so minus into minus plus 2, 1 3s are 3, 2 minus 3 is minus 1, cofactor of minus 3 is negative, this row and column is gone, 3 1s are 3, minus 6, minus 3 minus 6 is minus 9, minus into minus plus. Cofactor of 2 is 3 1s are 3, minus into minus plus, it is 7, correct. So therefore C dash is nothing but the adjoint of A. So adjoint of A is equal to, the transpose of this is minus 1, minus 8, minus 10, minus 5, minus 6, 1, minus 1, 9 and 7. Now therefore, you know the formula for A inverse. A inverse is equal to 1 over determinant of A into adjoint of A determinant. Now I will write the determinant. Now A inverse is equal to 1 over determinant of A into adjoint of A, that is 1 over determinant I will take. I will write the adjoint of A, minus 1, this is minus 8, minus 10, minus 5, minus 6, 1, minus 1, 9 and 7. What is the value of determinant of A from the previous step? So determinant of A is equal to minus 17, minus 17. Now therefore the solution x is equal to A inverse into B. What is x? This is x y z is equal to A inverse minus 1 over 17 times minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1 and 7 into D. What is D? D from the previous one is 814. This is 8114. So if I solve this, I will get the value of x, y and z. This is the method. Let me see what is the answer we are going to get. Hope you understood this. Now let me rub this part. Now therefore x is equal to A inverse B. So what is x? X, y, z is equal to A inverse minus 1 over 17 times minus 1, minus 5, minus 1, then minus 8, minus 6, 9, then minus 10, 1, 7 into, so 814. Let me multiply this. First row, first column. 3 rows, 3 column. This is 3 row, 1 column. You can multiply it. Minus 1 over 17 into 8 ones are 8, minus 5 ones are 5, minus 4 ones are 4. 8 eights are 64, minus into plus minus, minus 6 ones are 6, plus 9 into 4, 9. So 8 eights are 64, 6 ones are 6, 9 fours are 36. Next 10, 10 into 8 is minus 80, plus 1 ones are 1, plus 7 fours are 28. So this is equal to minus 1 over 17 times what is remaining. So minus 8, minus 5, minus 4 is minus 17. Next, so here what is this? Minus 36 minus 60. Minus 36 minus 60 is minus 70. Minus 70 plus 36. So this is nothing but 24. So 10 plus, that is 34. This is 34. So minus 34. See here, minus 8, minus 5, minus 4 is minus 17. minus 64 minus 6 is minus 70 plus 36 is equal to minus 34 again. So 28 plus 1 is 29 minus 80 plus 29. So this is 1, 7, 51 minus 51. This is minus 51. So therefore, if you divide by 17, what you will get? X, Y, Z is equal to divide by 17. 17 gets cancelled 1, minus minus gets 34 by 17 is 2. Again 51 by 17 is equal to 3. So therefore, the value of x, y, z is 1, 2, 3. So therefore, x is equal to 1, y is equal to 2 and z is equal to 3. So these are the values of x, y, z. So if you do this much, you will get 6 more. Very easy. And you should be very careful while solving this type of problems in science. If you miss one sign, the problem will go. The answer you won't get the answer. So even if you miss a small sign, addition and plus or minus, so the answer will changes. So therefore you should be very careful regarding the signs while doing this type of problem. So the value of x is 1, y is 2 and z is equal to 3. Now suppose if you want to verify whether the given whether the answer is correct or not, you can do the verification also. Let me verify this. Now let me take one equation. So let me take this equation, that is 2x plus y minus z is equal to 1. 2x plus y minus z is equal to 1. I will take this 2x plus y minus z is equal to 1. Substitute the value. What is x? 2 into 1 is 2 plus what is y? 2. What is z? Minus 3. 2 plus 2, 4. 4 minus 3 is 1. 1 is equal to 1. So therefore the answer is correct. X is equal to 1, y is equal to 2, z is equal to 3 is the correct answer. Right. So hope you followed this problem. Let me take one more problem of the same type. Let me take one more problem. This. Let us come to this. Solve x minus y plus z is equal to 4, 2x plus y minus 3z is equal to 0 and x plus y plus z is equal to 2 using matrix method. Same problem, same type, same method. So let us check it is in order not x, y, z, x, y, z, x, y, z. Now write down the value of a. Coefficient of x is 1, y is 1, minus 1, z is plus 1. Again, coefficient of x is 2, y is 1, z is minus 3. Coefficient of x is 1, y is 1, z is equal to 1. Now, and x is equal to, you know the value of x is x, y and z. And the constant matrix B is equal to 4, 0, 2. 4, 0 and 2. Now the solution is, what is the solution? The solution is x is equal to A inverse into B, where A inverse is equal to 1 over determinant of A into adjoint of B. This is the formula. X is equal to A inverse B and A inverse is equal to 1 over determinant of A into adjoint B. Now let us find out the inverse. For that, find out the determinant of A. Determinant of A is equal to determinant 1, 2, 1, minus 1, 1, 1 and 1, minus 3 and 1. So simplify this, plus, minus and plus. So 1 into 1 ones are 1, minus into minus plus 3, minus into minus plus 1, this is gone, 2 ones are 2, minus into minus plus 1 3s are 3, plus 1 into this row and column is deleted, 2 ones are 2 minus 1, 1 into 4 plus 1 into 5 plus 1 into 2 minus 1 is 1, 1 4s are 4 plus 5 plus 1, this is equal to 10. So determinant of A is equal to 10, not equal to 0. So the inverse exists. So determinant of A is equal to 10. Determinant of A is equal to 10. Followed. So check. Write down the coefficient of x, y, z. 1 minus 1, 1. 2, 1 minus 3. 1, 1, 1. So x is x, y, z. B is equal to 4, 0 and 2. The solution is x is equal to A inverse B. Therefore, A is equal to 1 over determinant of A into adjoint of A. So therefore, determinant of A is equal to this. Simplify, you will get it as 10. Now let us find out the cofactors. Now I will go to the next page. Determinant of this. 1, 2, 1, 1, 2, 1, minus 1, 1, 1, minus 1, 1, 1, again 1 minus 3, 1, 1 minus 3, 1. So you know the determinant is 10 already we got. Now the signs are plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus and plus. These are the signs. So let me check. 1 minus 1, 1, 1 minus 1, 1, 2, 1 minus 3, 2, 1 minus 3, 1, 1, 1. Okay. Now write down the cofactors. Cofactor of 1 is equal to, this is gone, 1 ones are 1, minus into minus plus 3, this is equal to 4. Similarly, cofactor of minus 1 is minus, this row column is gone, 2 ones are 2, 2 ones are 2, minus into minus plus 3, that is equal to minus 5. Cofactor of 1, so delete this row and column containing this, 2 ones are 2, minus 1, this is equal to 1. Now come to the second row. Cofactor of second row is 2. 2 it is negative sign, minus, this row and column is gone, 1 ones are 1, minus 1, minus 1. So minus of minus 1 is plus 2. Similarly, cofactor of 1. Cofactor of 1 is equal to, this row column is gone, 1 ones are 1 minus 1, 1 minus 1 is equal to 0. Again, cofactor of minus 3 is minus, this row column is gone, 1 ones are 1, minus into minus plus, 1 plus 1 is 2, minus 2. So I will write the adjoint directly. Adjoint of A is equal to, instead of writing cofactor and transposing, I will straight away go to the adjoint. So instead of writing first row, write it as first column. So adjoint of A is 4, minus 5 and 1. Second column is 2, 0, minus 2. 2, 0, minus 2. In the first method, the first problem, I took the cofactors and transposed it for adjoint. Now I am straight away taking the adjoint by writing the elements in column instead of in rows. Now come to the third row. Cofactor of 1. So this is gone, minus into minus plus, 3 minus 1, this is 2. Cofactor of 1 is minus into minus plus, 3 minus 1, 3 minus 1 is 2. Come to this element. Cofactor of this element 1, it is minus, this row column is gone, 1 3s are 3, minus 2, minus 3 minus 2, minus 3 minus 2, minus of minus 5, it is plus 5. And the last element, cofactor of 1 is, it is positive, 1 ones are 1 plus 2, 1 plus 2, this is equal to 3. Put it in last column, 2, 5, 3, 2, 5, 3. Now this is the adjoint. Now therefore A inverse is equal to 1 over determinant of A into adjoint of A. 1 over determinant A is 10. 1 over 10 into adjoint of A is 4, 2, 2, minus 5, 0, 5, 1, minus 2 and 3. Now the solution is, I will take the solution. The solution is x is equal to A inverse B. So that is nothing but A inverse 1 over 10 into, what are the inverse values? 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3 and B. B from the previous page, 402. 402 is the value of B. 402. 402. Now multiply this, first row, first column. So 1 over 10 into 4 4s are 16 plus 0 plus 2 2s are 4. Again 5 4s are 20 minus 20 plus 0 plus 5 2s are 10. Again 1 4s are 4 minus 0 plus 3 2s are 6. So this is 1 over 10 times 16 plus 4 is 20, minus 20 plus 10 is minus 10, 4 plus 6 is equal to 10. Divide by 10, what you will get? 20 by 10 is 2, 10 by 10 is minus 1, 10 by 10 is plus 1. So therefore, the value of x is 2, y is equal to -1 and z is equal to +1. So these are the values of x, y and z. Now divide 20 by 10 is 2, minus 10 by 10 is -1, 10 by 10 is equal to 1. So therefore x is equal to 2, y is equal to -1 and z is equal to +1. These are the values of x, y and z. If you want, you can do the verification. Substitute this value of x, y, z in any one of the given equation. The answer LHS is equal to RHS. Hope you followed this. This is very, very important. Practice, practice, practice. Definitely you will get these problems for 6 months. Okay. Now let us come to the same type of problem may be asked like this. Let us come to the same type of problem. Now, if A is equal to 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2, find A inverse. First find A inverse. Using A inverse, solve the system of equations. Now, if you observe carefully, A itself are nothing but the coefficient of x, y, z. Instead of writing coefficients, they have already given. And what? So, to solve the problem, x is equal to, what is the solution? X is equal to A inverse B. So, we should have to find the A inverse. That's also given. Find A inverse, that we know. So, what is given? A is given. See, 2 minus 3, 5. First row coefficient of x, y, z. Second row coefficient of x, y, z. 3, 2 and minus 4. And third row coefficient of x, y, z. 1, 1 minus 2. That is given. A is given. What is required to find is A inverse, then the solution. That's all. So, this is A given. Already A is given. What is x then? X is equal to x, y, z. And what is B? B is nothing but the coefficient of this. 11, constant terms, 11, minus 5 and minus 3. So, instead of writing A, they have already given. That's it. No problem. The solution is x is equal to A inverse into B. What is the solution? X is equal to A inverse B. Find out A inverse. That is what they have asked. Find A inverse. So, for solving, one should have to find the A inverse. So, find out the A inverse. So, A inverse. For that, we have to find the determinant of A. Determinant of A is determinant 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2. This is plus, minus and plus. So, 2 into, simplify this. 2 2s are 4, minus 4, minus into minus plus 4, minus into minus plus 3 into, this is gone. So, 2 3s are 6, minus into minus plus 4, plus 5 into, this is gone. 1 3s are 3, minus 2. So, this is equal to 2 into 0, plus 3 into minus 2, plus 5 into 1. So, this is 0, 3 2s are 6, plus 5 1s are 5, this is equal to minus 1. So, determinant of A is equal to minus 1, not equal to 0. Now, just go on finding the cofactors, adjoint and the inverse. Now, come to the next page. What is A? A is equal to 2 minus 3, 5. I will write in the next page. A is equal to 2 minus 3, 5. 2 minus 3, 5. 3, 2 minus 4. 3, 2 minus 4. 1, 1 minus 2. So, determinant of A is equal to, how much you got? Minus 1. Now, so just find out the cofactors. Cofactor of 2 is equal to, delete the row and column containing this, minus 4 minus into minus plus 4, it is 0. Similarly, cofactor of minus 3 is negative sign. This row column is gone. 3 2s are 6. 3 2s are 6. Minus into minus plus 4. This is minus of minus 2 is plus 2. Again, cofactor of 5 is equal to, this row column is gone. 3 1s are 3. Minus 2, that is equal to 1. First row finished. Come to the second row. Cofactor of 3 is minus. This row column is gone. This row column 3 2s are 6. Minus 1 5s are 5. This is minus 1. Cofactor of 3. Cofactor of this row column is gone. 3 2s are 6. Minus into minus plus 6. Minus 5 is minus 1. Next, cofactor of this element 2 plus minus plus minus plus, it is this row column is gone. 2 2s are 4 minus 4 minus 4 minus 5. So this is minus 9. Next, cofactor of this minus 4, it is negative minus, this row column is gone. 2 ones are 2, minus into minus plus 3, this is minus 5. Now I will write the adjoint A straight away. A, D, J. Adjoint of A is equal to, first row, instead of row I will write the column 0 1 0 2 1 0 2 1. Next, minus 1 minus 9 minus 5, minus 1 minus 9 minus 5, and come to the last cofactor of this 1 is equal to, this row column is gone. 3 4s are 12 plus 12 minus 2 5s are 10. This is equal to 2. Next, cofactor of 1 is minus, this row column is gone. 2 4s are 8 minus 8 minus 3 5s are 15. So this is minus 23. Minus into minus plus 23. Let me check this element. 2 4s are 8 minus 5 3s are 15. 15 and 8, 23 plus 23. Now cofactor of last element minus 2. This row column is gone. 2 2s are 4 plus 3 3s are 9, that's equal to 13. So 4 plus 9, 13. So 2, 23 and 13. These are the cofactor adjoint. Now therefore A inverse is equal to 1 over determinant of A into adjoint of A. Determinant of A is minus 1, 0 minus 1 to adjoint, 2 minus 9, 23, 1 minus 5 and 13. So therefore X is equal to A inverse into B. Now A inverse, since it is 1 by minus 1, multiply all the elements by negative sign, you will get 0 plus 1 minus 2 plus 9 minus 23 minus 1 plus 5 and minus 13 into B. What is B? I will come back to the problem. B is 11 minus 5 minus 3. 11 minus 5 minus 3. Simplify this. That's it. First row, first column. 11 into 0 0. 1 5s are 5. That is 1 into 5 is 5. Minus into minus plus 2 3s are 6. This is X, Y and Z. Now 11 2s are 22 minus 22 minus 9 into 5. Now X is equal to A inverse B. This is A inverse and B. So therefore what is this? X, Y, Z is equal to, let me multiply. First row, first column. 0 into 11 is 0. Minus 1 into 5 is 5. Minus into minus plus 2 3s are 6. First row. Now second row. 2 into 11 minus 22. Minus into plus minus. 9 into 5 it is 45. Again minus into minus plus 23 into 3. 3 3s are 9. 2 3s are 6. It is 69. Minus into minus plus 69. Next, minus 1 into 11, it is 11. Minus 5 5s are 25. Minus into minus plus 13 3s are 39. So this is equal to, what is the answer you are going to get here? 6 minus 5 is 1. So this is minus 45 minus 22 minus 45. This is 69 minus 67 plus 69. So that is 9, 7, 8, 9. So you will get plus 2 here. This is plus 2. And come to this. What is there? 39 minus 25 minus 11 is minus 36. So 39 minus 36 is 3. So this is equal to 3. So therefore the value of X is 1, Y is 2, Z is equal to 3. That's all. This is how we are going to solve. Same. So according to him, A inverse, this is the inverse. and the solution is x is equal to 1, y is equal to 2 and z is equal to 3. So if you do this much, you will get 6 marks. Very easy. So in this chapter, you will get 17 marks without any risk. So the very easiest chapter for passing package. Now let us come to the next problem. Hope you understood. Practice, that's all. Only practice, practice, practice. Now this is the application problem, statement problem. What is the problem given? Just the problem is like this. The sum of three numbers is 6. Let us consider the numbers. Let the three numbers be x, y and z. What is the problem given? The sum of three numbers is 6. Sum of three numbers means x plus y plus z is equal to 6. Sum of three numbers is 6. First point. Second, if we multiply third number by 3. Third number means z. 3z multiply by 3 and add second number to it. Second number to it means second number is y. Y plus 3z, we will get 11. That's all. So third number is multiplied by 3 and add second number to it, then you will get 11, means y plus 3z is equal to 11. And last point, by adding first and third number, x plus z, we get double the second number. Double of the second number means 2y. Represent it algebraically and find the numbers using matrix method. That means solve using matrix method. So this is the problem. What is the problem? Let the three numbers be x, y, z. What is the given condition? The sum of three numbers x plus y plus z is 6. Third number is multiplied. So if multiply third number by 3, if third number is multiplied by 3 and add second number to it, you will get it as the 11, sum as 11. So y plus 3z is equal to 11. And the third condition, first and third number, adding first and third number means x plus z. Adding first and third number, we get double the second number. Double the second number means 2y. X plus z is equal to 2y. So therefore, this given equation can be written in the form, this is the given equation. The given equation is x plus y plus z. X plus y plus z is equal to 6 and no x term. So therefore, 0x plus y plus 3z, y plus 3z is equal to 11. X and transfer this y, x minus 2y plus z is equal to 0. This is the equation. Solving this using matrix method, x is equal to A inverse B. So this is the formation of the equation. What is the equation? X plus y plus z is equal to 6. 0x plus y plus 3z is equal to 11. So the equation is, I will write here, x plus y plus z is equal to 6. 0x plus y plus 3z is equal to 11 and x minus 2y plus z is equal to 0. Now let me solve this. So I will rub the entire thing, I will solve this. Write down A. A is equal to coefficient of x. Coefficient of x is 1, 0, 1. Y is 1, 1, 1, 1 minus 2. Z is 1, 3, 1, 1, 3, 1. And x is equal to x, y and z. What is B? B is equal to 6, 11 and 0. The solution is x is equal to A inverse into B. Now find out A inverse. What is A inverse? You know A inverse is equal to 1 over determinant of A into adjoint of A. Now let us find out the determinant of A. Determinant of A is 1, 1, 1, 0, 1, 3, 1, minus 2, 1. So this is equal to plus, minus and plus 1 into 1 is 1, minus into minus plus 6, minus 1 into, this is gone, 1 into 0, 0 minus 3, again plus 1 into, this row column is gone, 0 minus 1. So this is equal to 1 into 7 minus 1 into minus 3 plus 1 into minus 1. 7 minus into minus plus 3 minus 1. 7 plus 3 is 10 minus 1 is equal to 9. So, determinant of A is equal to 9. Determinant of A is equal to 9. Now, so determinant A. Now, find out the inverse by finding the adjoint. Let me go to the next page. I will copy this. One, one, one. Next 0, 1, 3. Next 1 minus 2, 1. Now, this is A. Now, the signs are plus, minus, plus, minus, plus, minus, plus, minus and plus. Write down the cofactors. So, this is the adjoint. Determinant. Cofactor of 1 is equal to 1 ones are 1 plus 6 is equal to 7. Cofactor of 1 is equal to minus. This row column is gone. 1 into 0, 0, minus 3. Minus of minus, it is plus 3. Again, cofactor of 1 is equal to row and column is gone. 0 minus 1 is minus 1. Similarly, come to the second row. Cofactor of 0. This row column is gone. It is negative sign. This is 1 ones are 1 plus 2. This is minus 3. Cofactor of 1 is positive. This row column is gone. 1 ones are 1 minus 1 is equal to 0. Again, cofactor of 3. Negative sign. This is gone. 1 into minus 2 is minus 2 minus 1. This is minus of minus is plus 3. So, I will write the adjoint. Adjoint of A is equal to 7, 3 minus 1. 7, 3 minus 1. Minus 3 0, minus 3 0 and plus 3. This is 0. Next, last cofactor of 1. So, this row column is 1 3 is 3 minus 1 is equal to 2. Again, cofactor of minus 2 is equal to minus. This row column is gone. 1 3 is 3 minus 0 is minus 3. And the cofactor of 1 is equal to 1 ones are 1 minus 0 is equal to 1. So, this is 2 minus 3 and 1. Now, therefore, A inverse is equal to 1 over determinant of A into adjoint of A. 1 over determinant A is equal to, what is the value of determinant A? It is 9. 1 over 9 into adjoint 7 minus 3 2 3 0 minus 3 minus 1 3 and 1. Now, therefore, x y z is equal to A inverse into B. A inverse 1 over 9 into 7 minus 3 2 3 0 minus 3 minus 1 3 1 into B. What is B? B is nothing but 6 11 0. 6 11 0. Simplify this. 1 over 9 into first 7 this first row 7 6 are 42 minus 11 3 are 33 plus 0. Next 6 3 are 18 plus 0 minus 0. Again 1 6 are 6 plus 11 3 are 33 plus 0. So, what you will get? I will write here. I will change the pen. So, this is 1 over 9 into 42 minus 33, it is 9. And again 18 plus 0, it is 18. And 33 minus 6. 33 minus 6 is again, how much you will get? 20. Yes, let me check this here. Minus 6 plus 33. 23 minus 20 plus 23. Now, let me check. So, 1 over 9 into first row, first column. 7 into 6, 42. 11 3s are 33, 0. Again 6 3s are 18, 0 minus 0. 1 6 are 6, 3 11s are 33 plus 0. 42 minus 33 is 9. 18 plus 0 is 18. 33 minus 6 is equal to 27. Divide by 9, you will get 1, 2 and 3. So therefore, x is equal to 1, y is equal to 2, z is equal to 3. These are the values of x, y, z. So if you add, sum of three numbers is equal to 6, right? That is what given. 1 plus 2 plus 3, 6. What is the problem given? The sum of three numbers is 6. So x plus y plus z is equal to 6. X is 1, y is 2, z is 3. So that is the correct answer. This is one of the application of matrix and determinants. Now let us take one more problem of a different type, additional problem I will take. Now, what is the problem given? Already I solved this type of problem. Let me repeat. If A is equal to 2, 3, 1, 2 satisfies the equation, this equation is satisfied. So this type of questions they may ask for 4 marks. It's a 4 marker question. This satisfies A square minus 4A plus I is equal to 0, where I is a 2 cross 2 identity matrix and 0 is 2 cross 2 0 matrix. Using this equation, find A inverse. They ask to find A inverse. So for A inverse, what we'll do? 1 over determinant into adjoint of A. That is not the method here. Using this is called Cayley-Hamilton theorem. So this is the equation given. Using this theorem, one should have to find the equation given. A square minus 4A plus I is equal to 0. Multiply by A inverse. Now check actually what is the inverse you are going to get. A inverse is equal to 1 over determinant of A. 1 over 2 2s of 4 minus 3 into adjoint of A. 2, 2 minus 3 minus 1. So the answer you are going to get is 2 minus 3 minus 1 and 2. Let me check whether we will get this or not. So A inverse into A square minus 4 A inverse into A plus A inverse into I is equal to 0. This is A inverse into A minus 4 A into A inverse plus A inverse into I is equal to 0. So you know the formula. A inverse is I into A. Again 4 A inverse is I plus A inverse into I is equal to A inverse. So you know A into I is equal to A, that is also equal to I into A. A inverse is also equal to A inverse into A, that is equal to I. These are the formulas. So I into A is equal to A minus 4I plus A inverse is equal to 0. Now what we want to find is A inverse. So just keep A inverse and transfer. Minus 4I becomes plus 4I and plus A becomes minus A. 4 into I is 1001 minus A 2312. So this is 4004 minus 2312. Subtract this. 4 minus 2 is 2. 0 minus 3 is minus 3. 2 minus 0 minus 1 is minus 1. 4 minus 2 is 2. See here. 2 minus 3 minus 1 2. 2 minus 3 1. So without doing this, we should have to find the inverse. This is the method. That's all. So this is 4 mark per question. What is the condition given? If A is equal to 2, 3, 1, 2 satisfies the equation A square minus 4A plus I is equal to 0, where I is an identity matrix of order 2 rows 2 column and 0 is a null matrix of order 2 rows 2 column. Find A inverse then. A inverse. So given equation A square minus 4A plus I multiply by A inverse into A square minus 4 A inverse into A inverse I. So you know the formulas. A into I is equal to I into A. So if you multiply any matrix with an identity matrix, you will get the same matrix. A matrix into inverse is equal to an identity matrix. So A inverse is I, A inverse is I, A inverse into I is equal to A inverse, A into I is A, 4I, A inverse. What is required to find is A inverse, keep here and transfer. Minus 4I becomes plus 4I and plus A becomes minus A. So 4I minus A, 4 into I is 1001 is 0404 minus 2312. So that is 2 minus 3 minus 1 and 2. So that is the inverse. So that is how we are going to solve this equation, Cayley-Hamilton theorem. Now these are the problems based on matrix method. So this type of problems are very important. So at least you will get one 6-marker question from this practice. That's for the day. In the next class, we are going to study one more method to solve the simultaneous equations, that is called solving simultaneous equations by Cramer's rule, that is called a determinant method. Determinant method, or it is also called as the Cramer's rule, that we are going to study in the next class. So that's for the day. We will see in the next class with a different method, that is one more method to solve this type of problem, simultaneous equations, is the Cramer's rule. So using Cramer's rule, or it is also called as the determinant method. So that's all for the day. Let us meet in the next class. Thank you very much.